Now we're going to talk about literal equations. Now these equations are what I like to call unsatisfying, because a lot of times when we solve things, we always got like x equals a number, right? We got a nice number out and everything just kind of worked out lovely. These don't work out great. Your answers are actually just expressions. They're just a list of things. So they don't get kind of simple. They just kind of look yucky in the end. But they're useful in physics-based classes because you get to rewrite equations in different ways to help you solve different problems. And we may look at one like that at the end. I'm not sure. So let's do this one as an example. So let's say you're trying to solve for x. So you're trying to get x by itself. Ignore the u for a second. What would you do? You'd probably add the 2 over first, right? And there's nothing really to do there. You can't add u and 2. It's not like they're like terms or anything. It's not like you can add them together. So u plus 2 is just u plus 2. Like I said, a little yucky. Nothing kind of simplifies down. How do you get rid of the 2 in front of the x? You divide. And literally, that's your answer. That's why literal equations are called literal, I guess. Because literally, that's your answer. You could also theoretically simplify this down. If you divided both of them by 2, you could say u over 2 plus 2 divided by 2 is 1. Sure, but that's about as simple as they get, right? Let's do another one kind of similar to that. Let's do one that's actually is a physics-based problem. Okay, force is equal to mass times acceleration, which is actually a real physics problem you may see. Let's say you wanted to solve for acceleration. Well, all you'd have to do is you'd have to just divide by the m, right? Because that's how you get rid of things in front of x's. Even though these is weird because we don't have numbers, it still works out the same way. So to get rid of the m, you would just divide both sides by m. So that means acceleration is by itself now, which is our goal, is equal to force divided by mass, okay? This is, like I said, useful in physics classes because you tend to be able to solve different equations a bit easier like this, okay? Let's do another one. Let's do one that's kind of a chain of things just to kind of show you how that works too. Let's say you have, let's say g equals x minus c plus y, and we're solving for, let's just keep it as x this time, okay? So we move everything away from x. Well, this one's pretty simple. You just have to add over the c and subtract over the y. I'm gonna do this in one step. So that means I add the c and I subtract the y. There's nothing to combine. So it literally is just g plus c minus y is x. Literally, as I said, that's your answer, okay? The last one we're going to do is going to be a bit of an odd one. We're actually going to probably do 2 more to close. Now this one, these are going to be a little bit weirder. There's going to be something I'm going to introduce called a greatest common factor. Now, we know with numbers how that works, sort of. It's just kind of the biggest number that goes into everything. But when it comes down to letters and things like that and variables, it actually works the exact same way. You're kind of just looking for whatever's in common with our expression, okay? So let's start with a bit of a basic one for a second, okay? Let's do, I see one I want to do. I'm looking at a screen right now of different options. I like this one, all right? Let's do this one real quick. Let's do g equals 1 plus 2a over a. And let's say we're trying to get the a by itself. This is awkward because you have 2 a's. You got an a there and an a there. So let's just kind of just work our way around this. Obviously this probably is going to have more stuff to it. So let's get rid of this a first by multiplying by a. Because remember, when something's being divided, to get rid of division, you just multiply. So it becomes ag or ga equals 1 plus 2a. Well, we want all of our a's on one side, obviously. So this has an a, this has an a. So they probably need to go together. So let's move it over. Now, again, there's nothing to combine here. So literally, as I said, literal equations are called literally for that reason. ag minus 2a equals 1. Your a's aren't by themselves yet, are they? But they are on this side. Now, notice how they both share an a in common. This is what's going to be called factoring out GCF. So they both have an a in common, so I'm going to pull them out. So I'll pull an a out of this one, so this will just turn to a g, and I'll pull an a out of this one, it'll turn into a 2. It's kind of like the opposite of distributing. You're pulling that letter out that they share in common. So I'm going to highlight that to make sure I'm clear. There's an a here and an a here, and I pulled it out. It's the opposite of distributing. Now, a is being multiplied by all this. How do I get rid of multiplication? Well, I divide. Divide by g minus 2. You can put that in parentheses, you don't have to. And again, your answer is not really pretty. It's just a is equal to this, 1 over g minus 2. Again, quite yucky. But the concept still is there. All right, one last one we're going to do, and we'll close with this one. This one actually is a lot more straightforward than this. This has had a lot of moving around to it, okay? Let's do one that's a little bit more straightforward. Let's do this one. U equals kx plus yx. Right? Yeah, let's do that. Kx plus yx. And we're trying to solve, or excuse me, we're trying to solve for x. We're trying to get this x by itself. Now this one kind of relates back to here, this one we did, where we already had kind of everything by themselves. So let's pull out the x. So there's an x in common here. If I pull an x away from this term, it turns into a k. Now if I pull an x away from this term, it turns into a y. Like I said, it's the opposite of distributing. Then this equals our u. Now this is a lot simpler now that we've seen this crazy one here. Now we can just divide by k plus y. And it goes away there, goes away there. And like I said, literally, our answer is, I'm going to have to write this over here because I ran out of room, x equals u over k plus y. These are always hefty because, again, you don't get a nice answer out of it. It's not like you just get the number 3. Again, right here I divided by k plus y. I know that kind of got blurry towards the end. But these are literal equations. They never end pretty. But the concept still applies. All the same rules still apply.